Direct air capture, or DAC, is an important technological solution for removing carbon dioxide from the atmosphere. We believe carbon engineering's technology is capable of doing this at an industrial scale. This approach combines proven processes to remove large volumes of carbon dioxide from the atmosphere year over year, enough to help us curb global temperature rise to 1.5 degrees Celsius when combined with other global carbon reduction initiatives. The premise behind DAC is simple. Air is pulled into the facility with dozens of high-powered fans and sent through a series of processes that separate the carbon dioxide from other atmospheric molecules. The isolated CO2 is then converted into a liquid, which can be pumped underground to be safely and permanently stored, or used as a feedstock for products that improve our quality of life. A DAC facility will have large fans that draw air into each unit, where it is absorbed into a chemical solution of potassium hydroxide and water, which bonds to the CO2. This bonding happens as the potassium hydroxide flows across a highly engineered PVC packing system designed to increase the surface area and amount of CO2 captured. Once the liquid solution reaches the unit's outlet, the process of concentrating the captured CO2 begins. First, the solution is pumped into a piece of equipment called a pellet reactor. Calcium hydroxide is added, forming small pellets of calcium carbonate that hold the captured carbon. The pellet liquid solution is pumped into a centrifuge, where the pellets are separated from the refreshed potassium hydroxide. The pellets are then dried while the potassium hydroxide liquid is filtered and recycled back to the air contactors to capture more CO2. From the centrifuge, the calcium carbonate pellets are moved to a calciner, where they are exposed to high temperatures and converted into calcium oxide and carbon dioxide. The captured carbon dioxide is sent off to be compressed and either stored or utilized. The calcium oxide pellets are recycled back into the process. They are first sent to a slaker, where mixed with water, calcium hydroxide is formed and ready to go back into the pellet reactor, where it will be used again to create new calcium carbonate pellets. With the CO2 captured, separated, purified, and compressed, it can be permanently stored deep underground or used as a feedstock for new products such as cement, plastics, or even low-carbon fuels. Carbon engineering's DAC technology utilizes widely deployed equipment and processes in a new way that will help reduce atmospheric CO2 concentrations at scale. DAC has the potential to remove large volumes of CO2 from the atmosphere and create carbon removal credits that could help us achieve global climate and net zero targets. One of the most exciting things about direct air capture is that when deployed at a large enough scale, it may even help us achieve a net negative world by removing more carbon dioxide from the atmosphere than society emits, supporting a sustainable climate as the world continues to grow.
We're 1.5, and we make a difference.